Good afternoon, statisticians. This is Dr. Schulman. I thought I would make you a video because I know the last day in class, for those who are in person, I struggle with some of the chapter 7 stuff. So I just thought, why not just do, instead of doing like the homeworks again, I just got back from riding my bike and I was like, you know what? I should just make a big review for all of chapter 7. So that is my plan. I'm going to go through all the chapter review 7 questions. I also pushed back the dates for those. So that's what this video is. I know chapter 7's hard. Chapter 8 kind of makes a little bit more sense, at least to me. But chapter 7 is all about confidence intervals. And maybe after I go through the review, like all the questions, I'll be able to give you a better idea about it. So that's how this video is going to go. Again, I know I'm zooming a couple people on Monday, but if you need me, just reach out. I'm more than happy to help you with whatever you need. So I'm going to share my screen and I'm going to get right into it. And hopefully I can make this stuff really easy for you. But if I can't, that's okay. Let me get rid of my floating head. Probably because I am a little sweaty. You don't want to see that. So here we go. So where am I? You can go either through StatCrunch or not, but I'm just going to go to modules and hopefully I don't mess this thing up. Um, I'm probably going to use StatCrunch in Excel, and I also made a new notebook page for this. So we're in our course and we're in the chapter 7 review. See, I just pushed it back. Move back the dates for you guys. If you ever need me to move back dates, just let me know. So I'm going to open it in Pearson. And then while it's opening, we got a lot of problems to go through, but while it's opening, notice that I made a little extra one in Intro to Stats in your notebook for review. So that's what I'm doing. Um, so might as well just get into it. I'll do as many of these as I think it'll make sense for you. So we got 18 problems. Let's just get started. So here is our first one. A magazine provides the results of 500 adults who were asked to identify their favorite pie. Okay, among the 500 respondents, 11% chose chocolate pie. That sounds delicious. The margin of error was 5 percentage points. Describes what it meant by the statement that the margin of error was plus or minus 5 percentage points. Statement indicates that the interval from 11 plus or minus 5% is likely to contain the true population. I like that. The statement indicates the study is 100% minus 5%. No, I don't like this one because that's not really what it means. The statement indicates that the true population for the truck fly is in the interval from 11% plus or minus 5%. Okay. I don't like that one either. The statement indicates that the study is only 5% confident that the true percentage of, no, it's definitely not D. So I'm going to try A. Let's see how I did. Yes, 1 for 1. This one's just all about asking before I click next question. I'll move this. It's just kind of asking you what this means. This is saying 11% of the population, but the error is plus or minus. So it could be 16%, 11% chose Scarify, or it could be as low as 6%. That's what it means. It goes everything from 6% to 11%. I guess I should write that. So number 1, oops, sorry. I just clicked a different course. Obviously, you're not interested in the coordinate plane if you're watching this video. So for number 1, it said it was 11%, and the error was 5 percentage points. So to me, this means if 11% like it, it could be anywhere from 6% to 16%. That's what it means to me. And let's keep on going. Next question. All right, find the critical value Z of, oh, I should probably put them both side by side for you guys. Cool, so here we go. Here we go. And sorry about that. Let me make this like this. Perfect. So we're on number 2. Find the critical value that responds to the given confidence interval. So we have 87%. Okay. We want the confidence interval. So we just want a z-score for number 2. And this is z-score alpha divided by 2. So, okay, so find the critical value of z that corresponds to this. Well, remember, whatever we get, we're going to have to just take that alpha and divide it by 2. I know that's what it says, but it's a lot more complicated than it means to be. So where's my little StatCrunch one? I'm going to have StatCrunch right next to this as well. So let's put these two as best friends together. I can swing back and forth. All right, so this is what I'm going to do for this one. I'm going to go to stat. I'm going to go to normal. Sorry, I'm going to go to calculator. I'm going to go to normal. And if I'm going too fast, you could just let me know. So there's 0 and 1. We want this to be 87%. I need it as a decimal, 0.87. And I have 1.12. Now, I don't think that's right. That one doesn't sound right to me. So let's actually do this. I'm going to actually do this move. I'm going to do 100 minus 87, and then whatever I get, I'm going to divide it by 2. That's what my brain is telling me to do. If I'm wrong, guess what? We'll learn it together. So I have 13, and half of 13 is 6.5. So I really don't want 87%. I want 100 minus 6.5. Now, if that's too crazy for your brain to do, you could just do 100 minus 6.5. I got 93.5. So this is the one that I really want. And let's see if I am correct. So let's go to 0.935. Whoa. And we got this value. And they say round to 2 decimal places. So I look at 5.1. The 4 doesn't go up. So I'm going to put 1.51. Let's see if that is correct. Nice work. All right. So we're 2 for 2. So what did I do? First step was took 100 minus 87. I got 13. So this means my alpha would really be 13, but I actually have to take this alpha level and cut it in half. Well, what's 13 divided by 2? 6.5. 100 minus 6.5 is 93.5. And that is what I put in my calculator. If you like Excel better, if Excel is your best friend, I don't know why it would be. I'm just going to go to equals normal dot inverse parentheses. My probability was 93.935. My mean is 0. My standard deviation is 1. I should get the same answer and the same answer. Look at that. We're making magic. All right, so let's keep on going. All right. Express the confidence interval of 0.087 to 0.141 and type integers as decimals. I feel like I just write this in. Well, if you're ever confused about what they're asking for, I'm just going to put that number here and that number here. But let's view an example. Continue. Okay. Okay. That's exactly what it is. Okay, I thought there might be more to the question. So this is the lower and this is the higher. So you just type it in 0.087. Oops, put a little dash there. The next one is 0.141. Check answer. Fantastic. So what they're trying to ask you for this one is if they just give you a weird form, right? They're just giving you 0.087, comma, 0.141. What really happened? This is the lower one, and this is the upper one. Now, oops, that should be an 8. Now, what is this really? Could we actually find out the middle? Yes, we can add them together and find the average, and that will give us the error if we really want it. And then we could find that out. I know you don't need to know this, but I might as well show you some more stuff. 0.87 plus 0.141 is 1.011. That's the add. I'm going to divide that by 2. I now have 0.5055. That's the one that's right in the middle. If we wanted to know that, and what is the error? Well, you could either subtract that from this or subtract this from this. Either way, let's just minus the lower one, 0.87. Oh, okay. So I guess I can't go that way. I don't know. I was trying to do some fancy stuff to find the middle. I'm sure I'll get there, but as of right now, let's not even go too crazy about it. All right, so here we go. Here's the next one. I guess I rounded it wrong. Sometimes, obviously, skip through this part if you don't care about it. Plus 0.141. That makes sense. Now, oh, so this is no, that's just bigger than both of them. That's why I can't cut it in half, because if I cut it in half, it'd be lower. So I added these two things together. Unless I'm not. Oh, do I have it backwards? No. Am I typing it in wrong? I think I'm typing it in wrong. 0.87 plus 0.141. Nope, it is that way. So it's weird. It's so weird. Oh, because it's 0.087. Wow. Sometimes my brain does funny things. I wrote it right there, wrote it wrong on the calculator, but guess what? I still want to show you this. So 0.087 plus 0.141. Boom. So we have 0.228. Let's cut that in half. 0.114. So this to me is the middle. That is that value we're looking for. So that's like the actual average, the point average we like. And now if I just subtract this one from it, 0.087, I get the error. Yes, so this is another way to write the answer. I'm glad I didn't stop. So another way to write this answer is 0.114 plus or minus 0.027. There's your P, there's your error. Sweet. Whew. All right, let's keep on trucking. All right, so use the sample data and the confidence interval given to complete parts A through D. Ooh, long one. All right, a drug is used to help prevent blood clots in certain patients in clinical trials. All right, so there's our N. Gave us our N of 4,271. We got 134. Gave us nausea. Well, that sucks. And we have to construct a 90% confidence interval. All right, so find the best point estimated. Oh, so how much of the population has it? So it's always, so population is always what you want over the total. What do we want? Apparently to have an adverse reaction to some drug. 134, and we're dividing this by 4,271, and we want 3 decimal places. I hate this calculator, but it's the one that comes up nice on the screen. 4,271. So here's your first answer. They say 3 decimals, so we got 0.031. That's 1, 2, 3. Because this is a 3, don't go up more. So 0.031 is the first answer. No, let's go. Fantastic. Identify the margin of error. So we have to find E. The margin of error is usually a crazy formula. Some of these I forget. So I'm just going to go back in the notes for estimating population with means. I think that's what we're doing. So, because they said nothing about standard deviation. So where's the error formula? T-stat. All right. But I don't have a standard deviation. Another way I can find the error. Because we just have the mean. All right. So, I'm gonna use StatCrunch. I'm not gonna get too crazy about it. I'm going to go to stat. I'm going to go to, I guess I'm going to go to T-stat, one sample with summary. Our sample mean is just one way to try it. So our sample mean we just found was 0.031. But we don't have the standard deviation. Okay, so let's try a different way. Oh, actually, instead of me just messing around, I'll just view the example. So I did the first step, boom. The second step, it's binomial. Isn't that nice? So it's binomial because you either have the drug or not have the drug. So we can just use this formula. Man, sometimes I feel pretty dumb. Okay, cool. So the error was cool. Let's put that here and let me show you the magic. I thought we could just do it. I thought we could just let the computer do it for us, but that's okay. We're still on number 4. So error equals Z's alpha divided by 2 square root of you getting the adverse reaction, you not getting it, dividing by n. So we first need our Z-score, which should be pretty easy. I'm not going to look at the example for the rest of it. Well, maybe if we need it. So we know it's 90%. So I will go to stat calculator, normal. So this isn't 90. It's going to be 0.95. That's like the trick because it's the alpha's divided by 2. You need to see that again. Whoa, whoa, whoa. Why are you like hiding from me? All right, I'll do it again. Calculator. Here we go. 0, 1. It was 90, but we're going 0.95 here. For the fun of it, 1.64. That's our first number, 1.644. If you want it to be fancy, but I'll just put 1.64 square root of P, which is 0.031 times Q, which is 0.969. Oh, I got to show how I got that. So I did 1 minus 0.031 to get the other side, 969 divided by the 4,04271. I'm gonna use I'm gonna pull up as another aid. I'm gonna put a Desmos calculator so I can make it look pretty. So it's 1.64 square root 0.0031 times 0.969 little parentheses. So when I divide it, it's all under the thing. And the people was 4,271. Let's double check that. Looks the same, looks the same. So my error, 3 decimal places, 0.004. Keep on going. Excellente. All right, so here's our confidence interval. We just have to take the 0.031, add the 0.004. Cool. And then we just have to subtract it for the lower. And this just lets us know that 0.027 to 0.035, we are 90% confident that you're going to fall between this. This is the percentage of people who are going to have this error. I mean, have this adverse reaction. Okay. One has a 90% confidence that the interval from the lower bound to the upper bound does continue. Yeah, that's what it means. I'm not going to read the rest because these looked short. All right, let's keep going. All right, so here's number 5, a genetic experiment. Genetic experiment with peas resulted in one sample of 443 green. That's cool. And 158 yellow. Construct a 95% confidence interval. And the estimate of the percent. Oh, so we want the yellow peas. That's cool. And then based on the confidence interval, do the results of the experiment appear to be the contradict, oh, I don't know. So I'm just gonna do this one. I'm pretty sure it's the same exact formula. Good thing I have it right there. So E equals, there's your Z-score, but your alpha is divided by 2. So instead of 95%, we're really looking at 97.5. That's the big change, square root. Oh, so we want yellow. So here we go. We've got one. Oh, I first have to add them up. So 4, 4, 3 plus 1, 5, 8. That's my total. So I have 601 P's and we want to know 158. That's what we want to find out. That's what we're looking for. So 0.263. They always say 3 decimal places. So this is equal to 0.263. That goes here. Then I'm going to subtract 1 minus this. 1 minus 0.263. That's the other side, 0.737. And the whole thing gets divided by 601. And that's the whole thing. First thing I need is this value. So I have to just change this to 97.5. 1.96, nothing crazy. So this guy's 1.96. I'm just going to drop them in. So we have 1.96, 0.96. I have this one, which is 0.737. The other side was 0.263. And we're dividing this by 601. So I have an error of 0.035. I'm a liar, 0.032. There's your error. And all we have to do is add it and subtract it from 0.263. That's it. So 0.035. 0.035, and the error which we found was oh, sorry, that is the error. My fault. I'm human. So ours is actually 0.263. That's why you should be labeling and being on top of your stuff, unlike me, who's just kind of flying through it. But guess what? Still got the right thing. So we're between 0.228 and 0.298. 228. And the other one is 0.298. Fantastic. Well, 25% is 0.25. We're in there. Based on the results of the experiment period to come. No, it's in there. So 25% is there, so it works. All right, so let's try number 6. The brand manager for a brand of toothpaste must plan a campaign designed to increase brand recognition. He wants to first determine the percentage of adults who have heard of the brand. Oh, so this is an end problem. We have to figure out the end. These are always kind of tough. And remember, round up, always round up if you have a decimal. You want to be 80% confident. And we have 8 percentage points of error. All right, so that's 0.08. All right, cool. So let's figure it out. So what is the N formula? I'm pretty sure it's in 7.2. I keep looking at 7.2, but that's where I think it is. Where's the N formula? Is N? Here it is. But here we need a standard deviation. When we do not have the standard deviation, you take the range and divide it by 4 or use prior results. Oh, it's giving us 80%, 8 percentage points. All right, let's actually look at it. So if you ever get stumped, just show the problem. The sample size required to obtain this, 1 minus A times 100%. Without a previous estimation is given by the formula. Okay. Because a 90%. Is it just times 0.25 when you don't know? Oh yeah. I forgot. I forgot. Okay, so what does this mean? Let's get away from this. So if you don't know anything about it, I guess I just forgot this formula. There's two. One is if you actually have values for P and Q, and one is if you don't have values for P and Q. So I guess that was not in that section. So here's the two formulas for, I believe this is, oh, sorry, we're still on 6. Here's 6. So here's one of the formulas. N equals zeta alpha divided by 2. We're going to square that. And this is one where we have P and Q. Like this is if we know, like in our case, people know about the brand. That's your yes, that's your no. And we're just dividing it by E squared. However, we have no idea. So I don't know why they don't show you the full formula, but the full formula is like, well, if we have no idea, we're going to say 50% yes and 50% no. That's how they got this 0.25. And we'll put the error there. So this is the one we're going to use. This is if we know something. This is we don't know nothing. So here we go. First step is take this 80%. That's 20%. We'll subtract 100. We divide it by 2. We get 10. So really, we care about our 90% here. That's what that one goes to. And we have 8 error on our question. So it's 0.08 squared on the bottom times 0.25. And our z-score for 90%, 1.28. This is going to give us our error. 9 parts of this problem. All right, so here we go. So the first number was 1.28 squared. Cool. And then we're gonna multiply that by 0.25, put a parentheses here, divide the whole thing by 0.08 squared. And it's a perfect 64. So we don't have to round up. Fantastic. Assume that 79% have heard of the brand. Is that what we want or not heard about the brand? Well, I guess it doesn't matter what they're looking for, but either way, all I have to do is put the P, what we want, which is 0.79. I'm assuming that's what we want, and times it by the rest of it, which is 0.21. We'll always round up. So now instead of, should go down. Oh, because I forgot to put the decimal. Always, this should always be less people. See how it's less people? So well, if we're 50-50, like we don't know what should be more people here. We have 0.4 per person. So guess what? 43. Cool. More questions. Given the required sample size relative, can simply stand no. It's a convenient sample, not a simple random sample. I love A. It's not stratified. No, I'm going with A. Nice work. Okay, so we're up to a new question. So here's 7. Numero 7. An epidemiologist plans to conduct a survey. Oh, see, they're all 7.1. So I guess that's why I was looking in the wrong formula. I didn't know that they would give you this little bit, which is kind of cool. An epidemiologist plans to conduct a survey to estimate the percentage of women to give birth, how many to be 90% confident. So I have to do the same problem again, except now Z alpha over 2. This thing is going to be, we're going to have to find this with 95 being the percentage. So our Z score is 0.95, 1.64. That's the first number here. We know nothing before, so it's 0.5 times 0.5. And what's our error? Oh, I got to square this. What's our error? No more than 1 percentage point, so that's 0.01 squared. So I'm just going to drop these in. So 1 point, I already forgot, 64. Yeah. I know this is 0.5. You could just put 0.25 if you want. And this is 0.01. But I have to square this. Get out of here. Square it. A perfect 6,067.24. Boom. Fantastic. Now assume we have 82%. So if this should always be less. That's how you can tell if you did it right. So this one's going to be 0.18. And now instead of 6,000, we have 3,970 with the rounding. 3,970. Boom. What is wrong with serving? Randomly selecting adult women will result in an overestimate because some women will give birth to their first child after the. Okay. It would result in an underestimate because some women after would result in an overestimate because some women give birth to their first child. And will result in an underestimate because some women will give birth to their first child after it will be important to survey who have completed time in which they. It's either B or D. I'm just gonna go with D for fun. Nice. Recall that a simple random sample n is selected in such a way that every possible sample of the same size chance to be. This is the hardest part. The hardest part is doing the inferences. All right, time to keep moving on. All right, so now we're in a 7.2. Cool. So all that was 7.1, but number 8 is 7.2. So refer to the data set, complete parts A through C. We want a t-distribution. They're giving us the mean. They're giving us this. So they're giving us n is 50. I'm just going to do 50 minus 1 for the degrees of freedom, which is 49. That's your first step. For some reason, my numlock keeps going off. Step 1. All right, find the critical value. So it was usually going to be 95%, which is 5 for an alpha, but we cut that in half to get 2.5. So it's really going to be 97.5. But notice it's a t-distribution. So our calculator changes. I want a calculator for t. And degrees of freedom is 49. And now I have 0.975. So this is going to be 2.2 decimal places. Oh, 2.01. All right, let's keep on going. Well done. Give a brief description of the number of degrees of freedom. All right, the number of degrees of freedom from a collection of sample data is the number of unique that are determined after, I like B, the number of degrees of freedom for collecting of a random sample can vary. So basically, what degrees of freedom means, like, we could do this problem with 49 people instead of 50 and get the same answer. So I like B. Oh, sorry. Is it C? Okay. I'm human. I make mistakes sometimes. But that's how I think. If you read the definition in the book, this one's actually a really good job. So here, let's do 9. We have n is 36. We have a sample mean of 3216.7. We have a standard deviation of, a variance of 688.5. And we want it at 90% confident. So let's make some magic happen. Let's get that critical value. So your degrees of freedom is 35. And we have to make this 95 to get the value. So 35 and 95. So let's go for it. 35.95. Boom. So it's really going to be 1.6 two decimal places, 1.69, 1.69. All right, check the answer. Magic. Find the error. All right. I'm gonna see if I can cheat here. There's a formula here for error, which we can totally use. Totally use that. But let's see if we can just let StatCrunch do it for us. So let's go to Stat. If you want to see me struggle with the formula, I can do it. But I want to see if I can do this. I'm just gonna go to T. Oh wait, not calculator. We want to go to Stat, T-Stat, one sample with summary. We know we have a mean of 3216.7, 3216.7. We know we have a sample. This should be our variance. So I just have to square this number. So I got to square this thing. 688.5 squared. Or do I do, I have to square root this. Let's see. 68.5. I don't know. I can't remember. You know why? I'm human and I make mistakes. So let's actually look at it. I'm sure they're going to give us the formula. Got that. S is the standard deviation. So S is, see, this is what I keep forgetting. That's why knowing the things are so important. So S is the standard deviation, and we can use the formula is right here. I might as well show you both ways. So S is standard deviation. Man, I feel stupid. So S, standard deviation, S squared is your variance. Simple mistakes. So let's see if we can do this with, well, I'll write the formula. So I might as well do it by hand first. E equals T alpha divided by 2 times standard deviation over the square root of N. We have everything. We have everything. So it's going to be, ours was, oh, well, I already lost it, but that's okay. Get out of here. So, oh, sorry, it's 1.69 times 688.5. Make it a little smaller. Divided by the square root of 36. That's one way to do the problem. 0.69 times 688.5 divided by square root of 36 is 6. So we already have this 193.93. I'm pretty sure that's the error. To one decimal place, 193.9. Let's see if this is right before I look at StatCrunch. Cool. So let's see if we can do this with StatCrunch so we don't have to think. So standard deviation was 688.5. And our sample size is 36, and we want to be 90% confident. And as long as I show this critical value, that's going to be this guy. I'm sorry, that's going to be right here. That should be the 1.69. 1.69, beautiful. They don't give me the error, so I'd actually have to add or subtract these two together. So I can do everything but this, but at least it gives me the lower and upper limit. So we could take this and add or subtract it from the mean, but guess what? We have them right here, so we don't have to do that. So one decimal place, so 3022.8. And the upper is 3410.6. Check answer. Magical. Okay, so what was this last little bit, right? So we can take this error value and just add or subtract it from the mean. So 3216.7 plus 193.9. See, that's this one, the 3410. And if I subtract it, you get the other one. Write a brief statement about the confidence interval when we're talking 90%. One has 90% confidence. The interval from the lower end contains the true value. I like B. Usually it's the longest one, but that one made sense. Okay. Let's keep going. Now we're up to number 10. A data set includes 106 body temperatures of healthy humans. Okay, so we have an N of 106. We have a mean. This means sample mean, 98.7. And we have a S, see, no D. That's what always throws me off, 0.63. Okay. Construct a 99% confidence interval. What does the sample suggest? Okay, so let's first do the confidence interval. I'm not gonna do all that again. I'm just gonna drop it into StatCrunch, click options, edit. Our mean was 98.7. Cool. We have a sample standard deviation of 0.63. Cool. We have 106 people. Cool. And we want to be how confident? 99%. Compute. This is without using the brains and the tables and everything else. We have 3 decimal places. Okay, so 98.539. The other one is 98.601. Check that answer. What? Did I type anything in wrong? 98.7, 0.63. We have 106 people. All right. Well, I guess I could do it by hand. So 99 would be 1. 1 divided by 2 is going to be 0.05. So it's 995. So there's your first step. I guess I can go the long way. And then see where my little mistake was. See, we all make mistakes. I want a T. I want a T calculator. We have 105. And we have 0.995. Let's see if we get here. 2.62. And what was ours here? Sorry, 2.62. Yeah, got the same thing so far. 2.62, 2.62. All right, might as well just keep on trucking. So here we go. E. 2.62 times 0.63 over square root of 106. .62. Double check. Cool. The top was 0.63. And the bottom is the square root of 106, which means we have an error of 0.16. 0.161. Yeah, so I'm just going to go with, sorry. I have 0.160, so I'm going to go 0.16. All I have to do is add and subtract that from the value. So I go back to this, and I have to take the mean, which is 98.7 minus 0.16, 98.54. Okay, that's exactly what I had. Then I have to add this. 98.86. Did I type that one in wrong? 98.86. What did it say on StatCrunch? 98 point, I typed it wrong. 98.861. I just typed the thing wrong. So yes, don't do the math if you don't want to. Just let StatCrunch do it for you. Nice work. What does it suggest about the mean? No. No. Yes. 98.6 is there. We're fine. We're healthy humans. We're up to 11. Samples of DNA are collected, and the four DNA bases of adenine, guanine, cytosine, and thymine, or AGCT, are coded as 1, 2, 3, 4, respectively. The results are listed below. Conduct a 90% confident interval of the mean. What is the practical? None for me. All right, whatever. So I'm just gonna, now we have data, so I might as well just go 1, 1, 2, 4. 3, 3, 3, 4, 4, 2. Cool. If you click this, it'll happen, but there's barely anything here. So I'm just gonna go to data, sorry, stat, t-stats, one sample with data, variable one. I want to be what? How sure? 90% sure. And I always like seeing the critical value. Now I try to use this whenever they give me data. Why? Because I want to see, is it normal? Maybe a little normal. I don't know. It's up to you. Kind of like a line. Eh, kind of normal. I don't know. All right, so we have the lower limit and the upper limit. So let's just drop them in to one decimal place. So 1.8 and 3.4. I don't think this is useful data because they're nominal answers. Did I do this wrong? Did I type it in wrong yet again? Round to one decimal place as needed. We have, oh, because I put the critical T instead of the lower and upper limit. Where did I even get the 3.0? Oh, okay, so the 3.4 is right, but this should be 2.0. So don't make silly mistakes like me when you have the right answer right here. The given numbers are just substitutes for D and Ds. Yes, I love A. A makes sense to me. Cool, because they're just nominal names. They just gave them numbers. Doesn't give us real information. Okay, here's number 12. We're getting there. Listed below are the amounts of net worth of the 10 wealthiest celebrities. Conduct a 90% confidence interval. What does that show us? What does the confidence interval of the population mean? Oh, I'm just gonna do it again. Let's just copy to clipboard. Let's see if this works. Because I kind of don't want to have a new tab and mess everybody up. Nice. All right, so I'm just gonna go to stat, t-stats, one sample with data, variable two. We want this at 90%. I always look for the critical value, and I want to see how normal it is. Usually I look here. This doesn't look normal to me. This doesn't look normal to me. This is not normal. So I would say you can't use this data. There's some outliers. It doesn't make a straight line. So I would not use this data because it's under 30. So I don't care that we're 90% confident the data's bad. But here we go. One decimal place, 151.3. The other is 193 points. You got to round this up, 0.5. Cool. Good job. What does the result tell you? Nothing, because it's not normally distributed. Nope, nope, because the 10 are not a representative. Well, I like C. Well, I just don't like the answer in general. All right, let's keep going. No, it's not normal. Cool. All right, so we're still in 7-2. We've got a couple left. I'm gonna keep going. Sorry I did that one all on the computer, but we're just going right to 13. I did a couple just on the computer. So the pulse rates so here we go. We have an N of 156, vary from a low 38, okay, to a high 98. Interesting. Find the minimum sample size required to estimate the mean pulse rates of adult males. So we want this to be 90% confident. The sample mean is with 4. Okay, so we know that the error is 4. Notice that this isn't like percentage points. So here is where I actually have to use that formula that I kept thinking about, but it says 7.2. So I'm going to look in 7.2 for the N formula. Come on, N formula. Here it is. Look at that. So we have error. 4 is on the bottom. We have from low to high. But what do we do when we don't know it? So I don't remember how to get the standard deviation. We don't know it. So I might as well look at an example. There's the formula. Cool. Cool. We'll find that. Oh, I hate this rule of thumb. All right, so this range rule of thumb rule, I think is really foolish. I don't know why they use it. I can just take the biggest and the smallest and divide it by 4, but to me, that is like nowhere near finding the standard deviation. I don't like this thing at all. But guess what? That's what they want you to use. I don't think I can't pretend just cutting the max and the min into quarters will give me that value. I wouldn't personally use it if I was running the stats, but I want to answer the question and they didn't give me enough info, so I have to do it. So here we go. So let's get rid of this. 9 more parts. Wow. All right. Well, hopefully we don't have to look at it. And I just deleted the formula. All right. Well, so this is what they mean by rule of thumb. So it's max. I believe it's max plus min divided by 4. Let's look at it again. It's max minus min, so it's the range divided by 4. I hate it. Range divided by 4. So we need 98 minus 38 divided by 4. 98 minus 38 is 60 divided by, oh, sorry, I should be showing all of these. So 60, 98 minus 38 divided by 4, magical 15. So they're pretending our standard deviation is 15 for some reason. But here we go. Our N. And now I don't have to look at it anymore. Cool. All right. So first thing I need is the z-score. We want to be 90% confident. So 90% confident really means we have 10% outside of it. 10 divided by 2 is 5, which means we're looking at 95%. Calculator, z-score. So sorry, normal, which is the z-score. And we have 95. So 1.64 is our first number. Now, because of this rule of thumb, we're going to just claim that this is 15 and our error is 4, and we squared the whole thing. So 164 times 15 divided by 4 squared. So I have space here. So this whole thing is going to be squared 1.64. What was it? 15 times 15 divided by 4. So times 15 divided by 4. And I want to do that, another parenthesis, so the whole thing gets squared. So here's the sample size. We got 37.8, which is really me 38 people. Nice job. Cool. Assume, oh, look at that. So now it's different. So now we can assume that this is 10.8 based on the values from the sample of 156 people. Whatever. Oh, sorry, that's got to be a decimal. Now we only need 20 people for the study. I just put this in instead of the range rule they gave us. Compare the results from A and B. Which result is likely to be it? I would say the result from part A is larger than the result from part B. The result from part B is likely to be better because it uses a better estimate of the standard deviation. Because we shouldn't just guess on what the standard deviation is, because that's foolish to me. All right, we're up to 14. What do we got? 4 left. The accompanying frequency distribution summarize the data, randomly selected males in federal prison, use the data, construct a 90% confidence interval at the mean age of all federal people in prison. Okay, so using class limits from the 66 to 75, find the confidence interval. From the 60, okay, so for the over 65 group, I'm not quite sure how they want us to do this, so I'm just going to look at an example. To find the confidence interval, first find the sample size, mean, and standard deviation. Okay. Find the sample size are given by technology. We're not going to use the formula. All right, let's keep going. Cool. The sample is either random or it's bigger than 30. It is bigger than 30 for hours. We're going to use this formula, find the error, and then be 95% confident. All right, so we need the standard deviation first. So we need the mean standard deviation. Okay, let's just do it. So let's copy the clipboard. Let's see if this works. Get out of here. Get out of here. Hold it very top. Nice. So this is what we have. I'm going to do summary stats, columns. All I care about is number. Wait, how come the other one's not there? Oh, I need age and number. So summary stats, columns. Why does it only give me number, not the other one? Maybe because there's a parentheses there. Who knows? Stat, summary stat, columns. Nope. Oh, because that's a range. Compute. Interesting. So we have a mean. That's not really what it is, though. Well, formulas we use sample size mean for this exercise, use class limits. Okay, so this one's nice and tricky. What would I do? They're putting it right in the middle. So this is what they're doing. They're doing 25 minus 16. Oh, sorry, 25 plus 16 divided by 2. So 20, sorry, so we got 20.5. 20.5, and I need 12 of them. 20.5. I bet there's an easier way, but this way I'm going to do it. 20.5. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I need 60 of these. That's one way to do it. I guess I could just use Excel, but I've been doing everything in StatCrunch. 20.5, 30.5. Hmm. If I could do 30.5 times 60 and add it to it. Yeah, that's probably what I should do. All right, so my first step is I'm going to add all these up to get, I guess I have to do the math. And I'm probably going to use Excel for this, even though I said I wasn't. So here we go. Let's make some magic happen. All right, so cool. This is what we have for these. So the first thing I'm going to do is I'm going to add these up. It says my sum is 196. There's my sum. Now I need the mean of this. I need the average. To get the average, I'm just going to make a formula. So I'm going to do 20.5 times 12 plus 30.5 times 60 plus 40.5 times 67 plus 50.5 times 36 plus 60.5 times 16 plus, I guess I'll make this 70.5 times 5. Assuming that's what they did. So there's our first total. Do they use 70.5? Yeah, which I hate because anybody could be older than that. So to get this, so this is basically all of these together. Now all I have to do to make my average, this is like my grand total. This is like every number put together. I just have to take this to get the average and just do this number, grand total, divided by this number. So there's my mean. I have my mean. Ta-da. That's how I got my mean. And now I also have to get my what? My standard deviation. Well, standard deviation is a little bit tricky of a formula to try to do this, but that's okay. They did this. What's a good way for me to get the standard deviation? I know the formula. Standard deviation formula is just this x minus x bar, right? Squared divided by n minus 1 over the square root. Sorry, summation of this because we got to add all of these up. So it's every number of x minus x bar. So we have the average. We got the average. Could I do all of them? Since I have this grand total here, so I have the grand total, but I have to square it. Well, formulas of technology we use find sample size, mean standard deviation. This actually use the class limits of this, find the sample size, then round into one place. Because we have the summation of all the terms minus the summation of this times the terms. So I guess I'm just going to use this formula. I don't really want to use their formula to get the standard deviation, but I'm doing it anyway. So what do we got? We have equals n, which is 196, parentheses. Now we have our grand sum, but that just has to be squared. So that's our second one. So our grand sum being squared, that's our second one. So I'm going to have to square this term. And this would just be all of these terms times it. Okay. But you know what I'm going to do instead? I'm just going to write them out. So we have values, and I'm just going to do it the way that makes sense to me. I'm going to put mean. I'm going to put, instead of this, because I hate the way this looks. So I have the standard deviation formula, which is that. So I need the values, the mean, and then I need values minus mean. So it's going to be x minus x bar. I'm going to square it. X minus x bar squared raised to the second power. And then I'm going to find the total of that. So sum that. And then I'm going to divide it by a minus 1. So this one I'm going to do. So the first one, I'm basically just going to do this 20.5. And I'm going to go 12 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, and now I'm going to do 30.5 and I'm going to go down 60. I'm just going to go down 60 from 15 to 45. Boom. So is that 60 or is that 30? That's 30. So 15 plus 30 is 45. So I need 30 more. So I got to go down to 75. Cool. So I've got 12 of these. I actually have 13 of them. Look at that. So let's delete this line. So I have 12. Sure, there's an easier way to do this. So there's my 12. I better have 60 of these. Cool. I have 61. Let's get rid of one. Now I need 67 of 40.5. Because I have 78, 66, 67. Cool. And now I need 36 of 50.5. I need what? 36 of them. Well, 17, 27, 38, 36 of them. I need 16 of 60.5. Well, 13, 14, 15, 16. And I need 5 of 70.5. One, two, three, four, 5. 97, which is minus the top. Exactly what we need. Now we know our mean. Our mean was 40.445. I'm just going to use 3 deaths. Oh, sorry, 40.449. 40.449 is what I want. I'm just going to do a little subtraction. Perfect. Cool. Now I'm going to square them. Cool. That makes sense. I was like, why are these changing? Because they should be. Cool. Now I just need the sum of it, which is 25299.48. Or we can just do, if you want to go this way, you can go to home. Where's our happy sum button? Whatever, just equals sum. What are we talking? We're talking G2 to G198. All right, let's actually get rid of it. All right, so let's actually get the sum. Yes. 25299.47. So what's the last step? We have to divide it by n minus 1, and then we have to take the square root. So we just have to do, sorry, my phone wants to freak out on me. It's all good. Okay. So I just have to take this and divide this by n minus 1. So this will give me the variance. I just do equals this guy divided by n minus 1. Well, we know we have 196, so that's divided by 195. There's your variance, and then to get the standard deviation, you just have to square root. So equals square root this value. I know that took a minute, but I don't really want to mess with some other crazy stuff. So there's our standard deviation. Now we have everything we need to solve this thing. Cool. All right, so here we go. But since I have all of these now, right now, I could go the other way too. Since I basically made the data, but we might as well just drop it in as a data summary since we already did so much work for this problem anyway. So here we go, StatCrunch data, that we want to t-stat one sample with summary. Our sample mean was 40.449. Our sample standard deviation was the one thing that took forever to find, 11.3903. Our sample size was 196 people. We wanted to be how confident? We wanted to be 90% confident. And let's also see the critical value and compute. So we know it's between one decimal place. So we're talking 39.1 to 41.8. Just like me. All right, so check answer. Good job. Okay. Thought we'd have to do more for that, but that's okay. So let's knock out the last couple. Here's 15. We're finally in 7.3. So what are the requirements for constructing a confidence estimate for standard deviation or variance? So remember, this is your population. Since I did this wrong, standard deviation, and this is your population variance. So we'll just start with this. The sample size must be normally distributed, and the sample size must be greater than 30. It must be a simple random sample. I like this. I'm not quite sure of all of them, but I like C. I'm going C. I like simple random sample and greater than 30. That's what I'm going with. I'm going with D. That was the sample size. Sample must be a simple random sample. Oh, the one I had first. That's so stressful. Clicked on you first. Okay. So for confidence intervals, less strict. The requirement of is stricter. I don't know. I'm so curious. Let's just look at this. I have no idea. So for confidence intervals, standard deviation, the requirement of a normal distribution is stricter. The correct answer is stricter. and it cannot be waived for large samples. For a confidence interval, must be okay, that's fine. All right, interesting. So here's the last one. No, oh, sorry. The California Ford Owners, can the methods of this section be used to estimate this? I like D. I'm just going with D. It was no, but that's okay. Let's just go to the next question. So you can look at those. I'm human. I make mistakes. All right, so use the information. Okay, so we're just doing a chi-square. So here we go. So I'm going to go to stat. I'm going to go to proportion stats with summary. No, not proportion stats. We're going to go to, sorry, we're going to stat and variance stats. My bad. One sample with summary. There it is. So our variance, well, they gave us the standard deviation, so we have to change this to variance first. So we have to square it. So since we have 0.28, I have to square it to get the variance. So 0.0784. That's your first step. Our sample size is 26. We're not hypothesis testing yet. We will do that next week. But our confidence is now 99. Let's look at the critical value. Well, we know the degrees of freedom, but here's everything. So degrees of freedom -1 is still 25. Boom, boom. Nice. Our left is to 3 decimal places, so that's 0.042. Nice. What? 0.042. That's what I got. All right, so 0.042. Our N was 25. Oh, because I did the lower limit and not the lower critical chi-square. That's what they want. Sorry, so 10 point, how many decimals? 3. So 10.520 is what they want. And to the right is the upper, so it's 46.938. 46.93928. Good job. Now this is the confidence interval estimate. This is this one. So this is like our variances between the, sorry, our standard deviations between these two. So this is giving us our variance right here. See how it's the variance of the population, but we have to turn it back into what? Our standard deviation. So we have to take these two answers and do the square root of them. That's like the last step of this thing. So that's what I'm going to do. So 0.04176. Oh, I gotta do square root. So it equals square root of this guy. So there's our lower. All right, so it's 0.240. The other one is 0.18638, 632. So equals square root of this one. Boom. So that's what I believe the answer is. We'll see if I'm right or wrong. All right, so we got point, how many 2 decimals? 0.20. The other one is 0.43. Excellente. All right, here's the last one that we're doing. I'm just letting StatCrunch kind of like just work its way. But what is this really asking you for? We are 99% confident that the standard deviation of this answer falls between 0.20 and 0.43 milligrams. That's all it means. Just try to keep that in mind. And here's the last one. A clinical trial was conducted to test the effectiveness of a drug used for treating insomnia subjects. That's cool. After treatment with the drug, 15 subjects had a mean wake time of 90, okay, and a standard deviation of, okay, appear to be normally distributed. Nice. 90%. Oh, okay. So we might as well just knock it out. So I'm going to go to edit. There's our variance, our sample variance. Now they're giving us a standard deviation. So what do we have to do for the first step? We just got to square this thing. So we have a standard deviation of 41.2. So it's 41.2 times 41.2. So there's our variance, 1697.44. 1697.44. And we have a sample size of 15 subjects. Okay. And we want to be how confident? Well, we want to be 90% confident. All right, so let's compute this. Now we know that this is the variance of the population, but we want the standard deviation. So all I have to do is just square root these two values. And that's all I'm going to do. So I'm going to basically just change this one, and this one should change. So ready? 1, 0, 0, 3.351. Boom. See how that one changed? Isn't that nice? This one I'm going to put 3616.724. Boom. And that's our answers. So we want this to be 2 decimal places. So 31.68. And the last one is 60.14. Always look at the second one, okay, to change it. Nice work. All right, so is this thing effective? I guess I got to read it. Okay. So many choices. Clinical trial was conducted to test effectiveness of a drug treating insomnia in older subjects. After treatment with the drug, 15 subjects had a mean of 94.3 in the standard deviation, or no, 90%. Okay, does the result indicate whether the treatment is effective? Yes, the confidence indicates that the treatment is not, yes, it's not effective because the interval does not contain 94. No, because this is standard deviation. So we know A is out because that's a standard deviation, not a mean. So this makes no sense. No, the confidence interval does not indicate whether the treatment is effective. Okay, I don't know about B. Let's see. Yes, the confidence interval indicates the treatment is effective because the interval contains 0. No, it doesn't. So A is out, C is out. Yes, the confidence interval indicates the treatment is not effective because it does not contain 0 minutes. I don't know. Well, it doesn't contain 0 because 94 minus 60 and 94 minus 30 is still not there. Yes, the confidence interval. All right, so I'm gonna go with the 0 minutes ones instead of the 94.3s. I'm gonna say it is effective. And I don't think it contains it. I'm gonna go with F. I like F the best. So many choices. The confidence level is a probability 1 minus alpha does actually contain the parameter. Okay. So it's 10% chance. So I'm gonna do the one that's almost close to that. All right, I might as well try the last one that's almost like it. Oh, it's B. It's B. Okay, I like B the best. It doesn't really give me anything about it. That's okay. So that was pretty much everything. Hardest part is understanding what these answers mean. So why is this one B, in my opinion, in my humble opinion? Because this is talking about how much the standard deviation is changing, but not actually the mean. Since we're not talking about the mean, that's why I should have just went with B. Um, but that's okay, right? I missed 1.5. So try your best on this. I hope this was useful. Here, let me stop this. All right, so that was the whole thing. Um, so whether you're in class or online, I know I had a little trouble with the seven whatever ones last class, but I thought by showing you this entire review, you should have no problems with it. If you need me, I'm meeting with a bunch of, not too many. If you still want to meet on Monday, just shoot me an email. Or if you want to meet this weekend or whatever works. But I hope this was useful and reach out if you need anything.